All right, party people. Here is Unit PA Semester Exam Review video key. Number one, we are solving for x. There's various first steps you can do, but basically you got to subtract one of these things. So you can subtract 5x, you can subtract 8x, 7, or 12, it doesn't matter. I'm going to subtract 5x from both sides because I like to keep my x positive. So if I do that, I get 7 equals 3x plus 12. Subtract 12 from both sides, and you get negative 5 equals 3x. And then finally divide both sides by 3, giving us x equals negative 5/3. You can just leave your answer as a fraction. No problem. It actually saves you a step. Number 2, tell whether the following relations are functions. Explain your answers. State the domain and range. So is this a function? Well, we have a single output here that has single input here that has two different outputs. Sorry, that's supposed to be a 5. Don't know what happened to that. So that makes it not a function by definition. So therefore, it's not a function. The domain, however, is just list out all these numbers. So remember, that's where you do a squiggly bracket. Domain is 0, 1, 5, 7. And our range is 2, 3, 4, 5. You don't have to repeat the number 5, even though it happens for a single output. Actually, our range doesn't include it at all. So 3 would not be in our range. Sorry about that. But you don't have to write the 5 twice, even though it's used twice, technically. So there we go. All right. Over here, this is a function because there's no input that has more than one output. So every single input has exactly one output, and that's what's going on here. So negative 2 only goes to 4. There's no other negative 2 value that has a different y value than 4. And again, our domain is just a list of all the x values. Negative 2, negative 1, 0, 1, 2. And we use the squiggly brackets because, as opposed to interval notation, because there are no numbers between negative 2 and negative 1, for example, that are used. But if I wrote negative 2 to 2, this is counting all the numbers between negative 2 and 2, including like all the decimals and stuff, which is not going on here. And then our range is just a list of the y values, preferably in increasing order, so 1, 2, 3, 4. Notice how we do have a repeating range value, but graphically, that just means your y value is at 2 different places, which does not make the graph fill the vertical lines as like maybe the graph looks like this or whatever. But 2 points next to each other, okay. 2 points on top of each other, bad. All right. Determine if this graph represents a function. Explain your answer. State the domain and range in interval notation. So now interval notation, since this isn't just a bunch of random points, this is like a curve, like a smooth graph that has a bunch of, infinitely many points everywhere along the curve. It's not a function because it fails vertical line test. And then the domain in interval notation, that's the smallest x value that's used, which is negative 5 all the way out to 5. And that's going to be brackets because those numbers are used. And then our range, the lowest point is y equals negative 2, and the highest is 2. So our range is negative 2 to 2. Again, it's not a function because it fails the vertical line test. This hits in more than one place. As long as that happens somewhere, then it's not a function. All right, evaluate f of negative 3. This means we plug in negative 3 for x. You got to be careful with the negative here because this is negative 3 squared, which means negative 3 times negative 3. And then plus 2 times negative 3 minus 7. So negative 3 times negative 3 is 9, positive 9, and then 9 times 5 is 45. Sometimes students put too much trust in their calculator, and they type it wrong, and then therefore get the wrong answer. They type what they think they're supposed to do, but they actually mistype it, and the calculator does what they typed, which is not what the student intended. So this is 45 minus 6 minus 7, which looks like it's going to be 32. Okay, so that's just knowing what evaluating f of negative 3 means. Describe the transformations. I'm just going to say this in words, and then you can look at the handwritten key if you need to see it in more detail. But remember how this is a vertical shrink of 1/2. If there was a negative in front, it would also cause a reflection over the x-axis. This makes our graph go left 1, because remember how if it's attached to the x, it actually goes kind of the opposite of what you would think, which I've explained why in class. But if you don't know why, you could at least know that it does go left, and then this goes down 5. Also, I've changed the original. This should say g of x. I can't have the same letter on both sides. You don't really need to worry about that, but I think I changed the problem to look like that. Over here, now this is our parent function is a quadratic. Doesn't really matter. You should know that this makes it go right 6. This is a vertical stretch of 2. This flips it upside down over the x-axis, reflection over the x-axis. All right, so same thing going on here, right? An absolute value equation with the following transformation. So we're starting with the parent function. F of x equals absolute value of x. So that's what we're starting with. I'll call the transformed one g of x. So it's going to go right 3. So that's absolute value of x minus 3 on the inside. Up 4 is out here. Reflection over the x-axis is a negative. And a vertical stretch by 2 is the number right there. So that's what that looks like based off of all that information. Number 7, solving absolute value equations. Remember to check for extraneous solutions, which are numbers that we find that don't necessarily work. So first, I'm going to get the absolute value by itself. I'm going to add 6. So it's the absolute value of x over 7 plus 7. 3 out there equals 39. Divide both sides by 3. And you get absolute value of x over 7 plus 7 equals 13. Once you get the absolute value by itself, now we can set up our two cases, one of which is exactly what you see, x over 7 plus 7 equals 13. And our negative case is x over 7 plus 7 equals negative 13. Remember, this just represents a single number, so whatever you take the absolute value of, if it equals 13, you're good to go. If this equals negative 13, then you're still good because the absolute value of that is 13, which is why we set up these two cases. Now we solve these using the same steps, but we'll get different results. Subtract 7, and you get x over 7 equals 6. Subtract 7 over here, and you get x over 7 equals negative 20. And then multiply both sides by 7, and you get x equals 42, and x equals negative 140. Check for extraneous. These will both work, so you can just trust me on that. But that just means plug them in and make sure that they work. Okay, on this one, same idea. Get rid of the 2 right here. So you have absolute value of 3x plus 5 equals 6x. Now we can set up our two cases. We have 3x plus 5 equals 6x. And we have 3x plus 5 equals negative 6x. Subtract 5 and you get 3x, or sorry, don't subtract 5, subtract 3x, and you get 5 equals 3x. And so x equals 5/3. And on the orange one, subtract 3x again, you get negative 9x, and divide by negative 9, and you get x equals negative 5/9. So these are your solutions, but if you plug in negative 5/9 into this side, you're going to get a negative over here. This side will have to be a positive number because when you do the absolute value of whatever, you get positive. So you'll have a positive equals a negative, which means this answer can't actually work, and therefore it's extraneous. Extraneous. So that one doesn't actually work at all. Cross that one out. But I do want to see that as a solution that you found and that you check to see if it's extraneous. So there we go. All right. Compound inequalities. Just solve these. I didn't put any single inequalities on here, but these are just more complex versions of that. So if you can do this, you can do the easier ones. But for an OR problem, you just solve them separately. So on the first one, I'm going to just subtract 1 and divide by 2, giving us x is greater than or equal to 8. And then solve the other side. 3x is less than 9. X is less than 3. So this is an OR problem. So you just write the word OR. We need a number line. Remember on your number line, I just need the key numbers 3 and 8 in this case. Less than 3 goes this way. Greater than or equal to 8 goes this way with a filled in circle because it's or equal to. Okay. On B, so we still have a compound inequality. Like kind of pretend this isn't here and you solve this. And then also pretend this isn't here and you solve this one. But we can do them at the same time because the steps are the same. So first I'm going to add 4. I'll show my work on this one. I'm adding 4 everywhere, adding 4 everywhere. Giving us 16 is less than or equal to 2x, which is less than 24. Divide everything by 2. And you get 8 is less than or equal to x, which is less than 12. On a number line, that's where they go towards each other. So 8 and 12. You have x is greater than 8, but less than 12. So greater than 8 goes this way. Greater than or equal to 8 goes this way. And then less than 12, though, goes this way. So you can see how those are going to meet. So there's that. And then we have absolute value inequalities. Similar idea. We have our positive case. 4x plus 3 is greater than or equal to 7. This is a similar idea to absolute value equations, sorry. So like up here. But it does kind of turn into these problems, actually, because you're going to get two inequalities. 4x plus 3 is greater than or equal to 7. And then we have our negative case. 4x plus 3 is less than or equal to negative 7. And now you solve them both using the same steps. 4x is greater than or equal to 4. So x is greater than or equal to 1. And over here we have 4x is less than or equal to negative 10. So x is less than or equal to negative 10/4 or 5/2, if you want to write it like that. Okay, we can put these on a number line also, but I didn't ask you to do that. But it would be the same as putting them on a number line up here. On this one, before we set up our two cases, get the absolute value by itself. So the first thing I'm going to do is add 2, not that 2, this 2. So we get less than 12. Now we can do our two cases. 5x minus 2 is less than 12. 5x minus 2 is greater than 12. Coming back up here, we should actually determine if both of these can happen at the same time or not. Can you be greater than 1 and less than negative 10/4? You cannot, so this is an or problem. On the problem we're doing down here, we'll see that it's an and problem. We'll see how the answer looks a little different. But again, we add 2, so 5x is less than 14. X is less than 14/5. Over here, we add 2. 5x is greater than 10, so x is greater than 2. You can be less than 14/5 and greater than 2 at the same time. So you write this answer as a compound inequality where x is between two numbers. So you have 2 is less than x, but that's less than 14/5. So I wouldn't really care if you wrote your answer like this or not, but you know, it's a multiple choice exam, so one of your answers might be written like that, and you need to know that that's the same. Okay, piecewise functions. We have f of 8. F of 8, this is your x value. Look over here, where does x fit? Is 8 less than negative 2? It is not. Is 8 greater than negative 2? It is, so we're going to plug in 8 right here, and we get f of 8 equals negative 1/2 times 8 plus 2, which is negative 4 plus 2, so negative 2. This is just coincidence. It has nothing to do with those numbers whatsoever. From a graph, evaluate g of negative 4. So we go over to negative 4. And where is the y value at this x value? Well, it's that point right there. That's a hole, so there's no actual y value there. So the y value here is negative 3. So g of negative 4 equals negative 3. So that's just finding it from a graph of a piecewise function. And then when it's written, this is the same as above, but h of negative 2, we have to use the appropriate piece. Is negative 2 between 0 and 2? It is not, so we don't use this piece. Is negative 2 greater than or equal to 2? It also is not, so h of 2, negative 2 is undefined. it doesn't fit any of either of the pieces. I don't like how that F came out. Yeah, so there you go. That one's a little tricky. All right, write an equation that shows the transformations. You should know this is an absolute value function. If we go from this point to this point, that has a slope of 2. So it's, a slope of 1/2 because it's up 1 over 2. So that is our A value, which is the number that goes outside of the absolute value. So f of x equals 1/2 absolute value of x. Now, normally absolute value looks like this, the parent function. And so our vertex has been shifted left 3, down 2. So left 3 is plus 3 on the inside, and down 2 is minus 2 out there. So that's how you get that from a graph. And this one's similar, except our parent function here is square root. And then this one's upside down. So we know it's going to be negative square root of, and then normally square root looks like this, roughly. And so it's been shifted from here, 1, 2, 3, 4, 5, right 5, and up 2. So right 5 looks like that, and up 2 looks like that. And there you go. That is everything on the Unit PA review sheet.